separately. Sorry.
Здравствуйте, Александр Александрович.
Здравствуйте, Али, если по голосу не ошибся.
Нет, не ошиблись.
Здесь вот видите, как. Это уже хорошо. So, okay, let's start. Today we'll discuss about mass, force, and the weight, and so how they are act to the building. So the differences between these definitions and maybe features of each of them. So what is the mass? Mass of object is the measure of the amount of matter in it. So for us, mass can be called like the weight of some constructions. So the weight of number of main elements of our structure. So why we need to know the mass of the construction? Uh, because during making the analysis or calculation of any type of construction or building at all, we need to take into account their own weight and mass of each of the construction itself. So the amount of material, we call it like a kilogram. So kilogram is measure of maybe weight of any structure. So we call it, we make our measures in kilogram because it helps us to understand the weight of construction. So the kilogram and sometimes we use the tons. So in 1 ton, we know there are 100 kilograms. And so the smaller mass, which are called grams, gram 1000 grams in the ton. So for us, when we create the analysis, we're not use the grams, and the kilograms also not often are used, but we use the tons, especially tons per square meter. So there is definition ton per square meter. So it is load which are acting for 1 square meter in the which are measured in the kilograms. So how to find the mass of any construction? So it's not so difficult test, but it can be seen. We just to know about the density of the material. If we know density of material, we can find the mass of the material. We need to multiply density for the volume of this material. And the interesting position like mass stays the same no matter where you are in the universe. So it will not change anywhere. It will be the same in various positions in the various locations. So forces and the weight. So a force is a push or pull on an object. So for us, forces is one of the important things. So like the own weight of construction, which are dead load or statical load. So forces can be various according to their actions, statically, dynamically, varying loads, concentrated loads, and so on. So forces is important thing. So and here we are used not the kilograms, we use the newtons. So Newton help us to find the strength of the force or during the analysis or during the calculation of the building. So Due to knowing the forces, we can find the needable size of construction, needable form of construction, so and so on. So, according to the direction of its action, forces can be divided into the vertical direction, horizontal direction, um, and I think that's all for us. It's enough. For example, horizontal direction actions. It is the wind and the seismic loads. The vertical forces. It is the forces from all statical loads. And what is the weight? So it is a force and it should properly be measured in newtons. So gravitational forces between two objects depends on the masses of object and distance between them. So this gravitation force is called weight. So gravitational force. Actually, gravitational force is the own weight of construction. So for each of construction has its own weight. So it's a call it like gravitational force, but for civil engineers we call it like weight of construction, weight of material. Gravitational force depends on distance between two objects, and object weights change depending on where it is. So the farther away from the Earth, the less it weight. So look in comparing the weight and mass. So mass is not change um, uh, the weight during it will be located maybe universe, but if the object will be some far from us, the weight will be less. So remember, mass is the amount of matter an object is made of, matter of object is made, and weight is the force with which gravity pulls on an object. So look, in general, the position, mass, and weight, they are equal. But in the same time, the mass are not changed and the weight is changed if there are no gravity. So gravity for us, if we're constructed on the Earth, so there are nowadays no ways to construct anywhere like in universe. So we can say that mass and weight they're the same for us for construction, just for construction. But if we'll took another disciplines like physics, so we need to divide these positions, these definitions like weight and mass. They're different actually. So that's important to remember. So force, structures and force. Force is a push or pull that tends to cause an object to change its movement or shape. So during design the building, we need to apply many forces, and each of that forces have the effect on the structure and can move the structure and so on. And all that effects are depends on magnitude or size on force. So the bigger the force's magnitude, the stronger it is, and the more effect it will have on the structure. So magnitude or size, what does it mean? For example, wind. So according to the place of the location of the building, the force of the wind can be increased. Actually, on the open space, in the free spaces, if there are no huge constructions, huge building, which are located nearby to our existing building, of course, our force from the wind, or magnitude of the wind will be increased. And of course, it will shake our building with the more effect. Then, for example, if our building will be located in central part of the city when there are many huge buildings, many story buildings which protect our building from the huge pressure of the wind. So magnitude is important thing. Magnitude is also applied, the definition applied for the seismical activity force. So to study the how strong was the seismic earthquake, so we use the definition magnitude. So it's a force which are um, act to the building and give it effect to the construction. Direction of the force. So previously I told you about direction. So the most popular type of direction, it is direction from the x, so it's a horizontal direction from the longitudinal part of the building. The y-axis, it is direction from the cross-sectional part of the building, shortest part of the building, and the z direction, zx, it is the vertical direction. So which are directed from the bottom to top part, or in opposite from the top to the bottom, like own weight of construction is have the opposite direction from top part, so according to the gravitation to the down. Yes, so it's push with its own ways from top part to the bottom level to the earth to the foundation and so on. So different size road tell us a little about magnitude, direction, and location. So on the picture you can additional see about um, the types. So on the next slides we'll more deeply talk about compression, tension, shearing, torsion, and bending. And here you can see some information about compression. So compression is a magnitude which are give it forces, and from top part to the bottom part, and here we see the compressive strength. So it works in opposite direction from bottom part to the top part. Tension, um, which are gives the tensile for constructions, and here I can define the tensile strength. It has the opposite direction, and the torsion and the torsional strength. Torsion, mm, it's a force which try move or rotate our building from the z-axis. And torsional strength is a resistance which resist the building from the torsional force. So look at this positions or maybe definitions, five basic types of force actions, which I illustrated here. So there can be found five main types of forces acting to the construction, for acting to the each of construction during the building exploitation time. So it is compression. So compression force crash material by squeezing it together. So squeezing it together with this push when from two parts of the construction, or maybe from one part if other is a rigid part. So there are a compressive strengths which try to compress the construction, and the construction itself, actually the material from which made this structure, try to withstand it to prevent the losses of the shape, prevent the fractures, cracks inside, and all failures. So next, tension. So tension force is to stretch a material by pulling its ends apart from central part to two parts, right and left part. So it's a try to pulling its ends. So tensile strength measures the largest tension force the material can withstand before failing. So again, according to the material, just a material help to the structure save its initial positions, mm, without any cracks, without any failures, and so on. So each material has its own characteristics according to the tension, compression, and the other variant of actions, and so on. So the more density of material, the better it showed results for some of these actions, not for all, because each of material have its own good benefits or according to the resistance to these force actions, and in opposite not good show good results again to these forces. So that's why knowledge about how work this or another type of material, um, how work materials in combinations between each other, it is important thing during applying the type of material, the quality of material, and so on. Shearing. So shear force bend or tear a material by pressing different parts in opposite direction at the same time. So like you see on the picture, so we try to mm, just make the tear of material. So and when it work in opposite direction from two parts, of course not each material can withstand it. So without failures. So, and here can be used example like bridge beam. So bridge beam, which have two supporting points, supporting piers, um, is a good example for the shear force. So torsion forces twist a material by turning its ends in opposite direction. So torsion strength measures the largest torsion force a material can withstand the steel spring back into the original shape, so causing, for example, the twisting of bridge deck. Um, Again, so example, you see the bridge. So bridge constructions is every time good examples. Like beam is a bearing construction for bridge, and bridge deck, it is a horizontal pavement. So it's a part where all vehicles are moved. So they are moved on the deck. So, and the deck is a horizontal slab pavement which are acted every time by the torsion forces. So, according to uniformly distributed load acting from the vehicles from the transportation systems, which are every time move every day on the pavement. And the last one, it is bending. So combination of tension and compression. So when in the same time there can be found the shear and torsion forces uh, are also a combination of tension and compression and extension of example of the bridge beam. So during the design of the building, most of all, there can be found the combination of the forces, because not each of construction create the just a simple way of force action, like only compression or maybe only tension. So most of all, there are found the combinations between them, between each of the five types of forces actions. And so, how to distinguish each of these types and how to create the combinations between them. Of course, it's an open question, and the civil engineer should solve it by itself by taking into account all knowledge of physical characteristics of the material, about knowledge in the field of building constructions, about engineer graphics and so on. So there are many pieces of knowledge which can help you to see all picture of construction in the one time. So only in that way you will understand right understand how each construction withstand the loads and what type of loads act in the same time. So there are combinations of load or not just a separate load act to the construction. So they are all depends on the building, on the construction, on the size of building, shape of building, and so on. So load. The load is an external force on a structure. So look at another definition. Actions, force actions was one position, and now the load. So load is the additional external force on the structure. So when we know the weight of the construction or weight of the load, and we added to the construction because it is calculated load. For example, when we make the calculation of the building, we know the force, for example, of some of materials. For example, it will be covering. We know that the content of the covering, so from what material it are consist, and we can find the load. So it means that the material of the covering will be the load on the construction. Like you see on the picture, for the bridge, the own weight of the car, it will be the load for this bridge. And so also in addition, you see the internal forces acting on the bridge and the external forces. So internal forces and external forces um, are found in one time, but in the opposite directions. Yes. So static and dynamic loads. Uh, these two type of loads are most often find type of loads during the design of the building, because all of loads, dead loads, own weight of materials, constructions are the static. So the definition static load is permanent force acting on the structure, includes the weight of structure itself, non-moving parts of its supports. So non-moving parts. So if there will be moving parts, it will be some actions. So we call it like action. Dynamic life load. If previous one was dead load, the dynamic load is life. So load is changing or not permanent force acting on structure. So not permanent like the static loads. Static loads, it's the designable or calculated weight. We know it. But dynamic is not permanent at all. Includes the forces of winds, weight, um, weight of things that are in or on structure. Yes. So different kinds of structure are designed to withstand different loads and the forces. Different bridges are built for different purposes, types of the bridge. So we'll not actually look at the construction of bridge, especially. But here we just there was showed to understand the main purposes for what type of bridge can be used when we know some purposes of it. So beam bridge. So beam bridge when there are main elements of uh, construction. So bearing construction is a bridge. So it's the most common. Used a flat beam supported at each end. So the ends is supported by the vertical supporting elements. So here, truss bridge. So truss bridge can help us to cover the long span construction, the long span structures in the water line, and sometimes in the lakes, in the seaways, and so on. So the main features lightweight, strong bridge made of truss, triangle-shaped frames along its side. So triangle-shaped trace is only one of the popular types of the frames. There can be also used the other variants like trapezoidal shaped frame, squared shaped frame, and so on. And also they are divided into the material which are used for the frame tracks. Suspension bridge. So suspended bridge, the bridge which are used the special tires, which help to suspend the bridge, and these ropes used for suspension are made from the high quality steel rods. So hands between two ends, towers that hold it up. So here you see the two hands. So this is suspension. Smaller cables attach the rod to the handing cables. So this is the suspension of the bridge. And arch bridge. So arch bridge, it is the shape of the bridge. It's designed to withstand heavy loads. Roman aqueducts are a good example of this type of the bridge. So Roman's aqueducts. Do you know what does it mean, aqueduct? Who knows? Have you ever heard about the definition aqueduct? No?
No.
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 Romans. Uh, we know that Romans is the ancient nation, yes? So from that time, there wasn't the pipelines which helped to deliver the water from, for example, lake to the city and so on. There wasn't any pumps which helped move it more quickly and so on. And so the aqueducts was the constructions, man-made constructions, which help people to deliver water from one place to another place by using its own pressure. So it has a slope which help them to put for example, water in long distance actually from one place by using just the water pressure and its opportunity to move if there will be some slope. And so they was used for watering their gardens, for some domestic purposes and so on. So they call the um, pipelines, they was open pipelines. Actually, it's not the pipeline like we use it nowadays. It was just construction, open construction, which was constructed above the ground. So like you see on the picture here, so by using the slope, There was used arch bridge for supporting points, um, and they are constructed aqueducts. So it was really one of the important construction at all time. So, right, interesting, maybe history, maybe it was a real story. So I will tell you about it some later.